At 10:05 p.m. on June 24, 2026, a stretch of the Venezuelan coastline moved 175 kilometers in a single motion. Not a crack, not a tremor. An entire section of the Caribbean plate boundary let go at once, and the rupture didn't stop where anyone expected it to. It kept going, east toward Caracas. We are going to uncover exactly what happened along that fault line, why the pattern of this rupture has seismologists more concerned than the magnitude alone would suggest, and what history tells us about what might come next. Northern Venezuela sits on one of the most active and most overlooked plate boundaries on Earth. Here, the Caribbean plate grinds eastward against the South American plate at a rate of roughly 20 millimeters a year. That might sound slow. It isn't. Over decades, that motion builds enormous stored energy along two major fault systems, the San Sebastian Fault, tracing Venezuela's northern coast, and the Bocono Fault, cutting inland to the west. Together, they form a fracture zone that has produced some of the deadliest earthquakes in South American history. The region's most devastating modern quake struck in July of 1967, a magnitude 6.6 event near Caracas that killed approximately 240 people and collapsed multiple high-rise apartment buildings in the capital. Since then, this stretch of coastline has seen a string of moderate but damaging earthquakes, a magnitude 6.4 near Moron in 2009, a magnitude 6.0 near Valencia in 1989, a magnitude 6.1 to the west in 1975. But nothing since 1967 had approached the scale of what happened this June. And here's the detail almost no one caught in the first 48 hours. In September of 2025, just months before this event, the same region experienced something called an earthquake doublet. Two significant quakes, a magnitude 6.2 followed by a magnitude 6.3, striking in rapid succession to the west-southwest of this year's rupture zone. That sequence alone injured over 110 people and caused extensive structural damage across two Venezuelan states. At the time, it was treated as an isolated event. Now scientists are asking whether it was a warning. On the night of June 24th, the fault let go along a stretch approximately 175 kilometers long and 20 kilometers wide. USGS finite fault modeling, the same technique used to reconstruct how energy releases across a rupturing fault, shows this was not a simple symmetric earthquake. It ruptured unilaterally. That means the fault broke in one direction only, starting near its onshore epicenter and tearing eastward, offshore, toward the waters just north of Caracas and La Guaira. Stop for a second. Let that direction sink in. Caracas is home to nearly 2 million people. La Guaira is the country's main international airport and seaport. The rupture didn't move away from the capital region. It moved toward it. Preliminary analysis places the epicenter within either the eastern segment of the Bocono Fault or the western segment of the San Sebastian Fault, with rupture propagating onto the San Sebastian system as it moved offshore. This is the kind of unilateral, directional rupture that seismologists watch closely because it concentrates shaking intensity in the direction the fault is breaking, which in this case was straight toward one of South America's largest urban populations. If the historical pattern holds, this is where the story gets more complicated. In the immediate 250 kilometers surrounding this event, there have been only 7 earthquakes of magnitude 6 or greater in the past century. That sounds reassuring, until you remember that the September 2025 doublet occurred in that same radius less than a year earlier. 2 significant ruptures on the same fault system within 9 months is not typical background seismicity. It's the kind of clustering that raises the question seismologists are now debating quietly. Is this fault system unloading stress in stages, or is it building towards something larger? Triggered landslide hazards are already being documented across the mountainous terrain surrounding the rupture zone, a direct consequence of the shaking's intensity and duration. In steep coastal terrain like northern Venezuela's, a strong earthquake doesn't end when the shaking stops. Saturated slopes, destabilized by the tremor, can fail for days or weeks afterward, especially if rainfall follows. If the region sees significant precipitation in the coming weeks, secondary landslide events become a real possibility layered on top of an already damaged infrastructure system. Consider what that actually looks like on the ground. A hillside road above a coastal village doesn't need a second earthquake to fail. It just needs one more heavy rainstorm on top of soil that's already been shaken loose from its foundation. Engineers surveying the affected zone in the days after the main shock have flagged dozens of slopes as unstable, and in a region where roads often serve as the only route between isolated communities and emergency services, a single landslide can cut off aid to hundreds of people for days. This is the part of the story most news channels missed entirely. The earthquake was the beginning of the danger, not the end of it. There's also the matter of aftershocks, and this is where the numbers get uncomfortable. For a rupture of this length and magnitude, seismologists expect aftershock sequences that can continue for months, occasionally producing events strong enough to cause additional damage to structures already weakened by the main shock. Buildings that cracked but didn't collapse on June 24th are now sitting in a kind of structural limbo, standing but compromised, waiting for the aftershock that either they survive or they don't. To understand why this earthquake behaved the way it did, picture a long strip of fabric being torn by hand. If you start the tear in the middle and pull evenly in both directions, the tear spreads symmetrically and the energy releases gradually. But if you anchor one end and pull hard from the other, the tear rips fast and hard in a single direction, and everything in that direction takes the brunt of it. That's unilateral rupture. The June 24th earthquake tore like the second scenario, anchored near its onshore starting point and ripping east, offshore, with the energy of the rupture directed like a wave toward the coast near Caracas. This is also why two earthquakes of the same magnitude can produce wildly different outcomes. A symmetric rupture spreads its energy in all directions, softening the impact anywhere. A directional rupture, like this one, can produce significantly stronger shaking in the direction of propagation than the magnitude alone would predict. It's part of why USGS scientists don't just report a number and stop. They model the geometry, because the geometry is often what determines who gets hurt. There's a second mechanism worth understanding here too: stress transfer. When one section of a fault ruptures, it doesn't just release energy, it redistributes it. Imagine pressing down on a bruised apple with your thumb. The bruise under your thumb might not spread further, but the pressure pushes outward, weakening the tissue just beyond where you pressed. Fault segments work the same way. A rupture on one section of the San Sebastian fault can increase stress on the adjacent, still locked segment closer to Caracas, meaning the area seismologists are most worried about right now isn't necessarily where the earthquake already happened. It's the segment right next to it that hasn't broken yet. Zoom out, and the human dimension becomes difficult to ignore. This is a fault system running directly beneath a coastline that houses millions of people, a major international airport, critical shipping infrastructure at La Guaira, and Venezuela's capital, just a short distance inland. Communities across Zulia and Lara states are still recovering from structural damage tied to last year's doublet sequence. Damage that, in some cases, had not yet been fully repaired when this year's magnitude 7.5 event struck the same broader region. Engineers assessing building stock across the impacted zone face a familiar and troubling reality. Much of the region's older construction predates modern seismic codes, the same vulnerability that turned the 1967 Caracas earthquake into one of the deadliest disasters in the country's history. A structure that survived the September 2025 doublet with hairline damage may not survive a second larger event landing in the same weakened footprint. That's the quiet danger of clustered seismicity. It's not just about the next earthquake, it's about what the last one already broke. Put the scale in perspective. Nearly 2 million people live in Caracas alone. Add the surrounding metropolitan area, the port communities near La Guaira, and the towns scattered across Zulia and Lara still rebuilding from last year. And you're looking at a population exposed to this fault system that rivals the size of Houston, Texas. That's not a regional story. That's a story about one of the most seismically active capital regions in South America, sitting on a fault that is now ruptured twice in less than a year. So what happens next? USGS scientists continue to monitor aftershock activity along both the San Sebastian and Bocono systems, watching closely for any signs that stress has migrated further east, closer still to Caracas, or that the western segment near last year's doublet could be next to release. Geodetic surveys, including INSAR satellite data, are being used right now to measure exactly how far the ground shifted and where remaining strain may be concentrated. The question seismologists won't answer with certainty is the one everyone wants answered. Is the fault done, or is it just getting started? History suggests this region doesn't rupture once and go quiet. It clusters, it repeats, and sometimes it saves its worst for last. The answer to that question may come sooner than anyone expects. Subscribe to stay ahead of what's coming.